1.7.
Like that.
Solve absolute value equations and inequalities. So if you didn't do the notes, you need to make sure that you do them later for
Our trophy got promoted
Tomorrow.
from the floor to the table.
What?
Our trophy. It was there, now it's there.
What's it for?
They're inflated.
All right, decide whether the given number is a solution of the equation.
What?
So 4 is the absolute value of d plus 6 is equal to 10, and the number that we're seeing if it works is negative 4. All right, so I plug in negative 4 for d.
Oh, no, it turns to
So the absolute value of negative 4 plus 6.
It works.
Let's see if it can do it.
Well,
Is equal to 2, which is not equal to 10, so it is not a solution.
I thought absolute.
I thought you like.
I
You
thought
add them and
absolute
then you do
value.
the absolute value.
Wait.
You have to do this up inside the absolute value. It's like a grouping symbol. You do it first, and then you...
I was
Yeah.
thinking
Do it.
all wrong. Yeah. Okay.
Where did my 2 go?
It
Not
got
a-
deleted for some reason. Because it's trying to auto math everything.
Even though I literally turned it off, and it still did it. I lost my shoe.
You lost your shoe. It's upside
I
down.
can't get
It's under
it.
the chair.
I can see
I got it. Okay.
Are those the new glasses?
that was like the old one.
Why are you wearing them?
Because the other one's moved my eyes hurt.
Wait, why is
All right, 8. The absolute value of 17 minus 8r is equal to 15, and the number we're plugging in is 4. So I've got the absolute value of 17 minus 8 times 4.
Wait, R is 4.
Yes.
Oh.
So that's the absolute value of 17 minus 32, which is
Wow. 17
Which is
the absolute value of negative 15, which is equal to 15, so it is a solution.
Oh, I remember.
Why is there an N?
Solution?
Yeah.
So it's not just soul.
Oh, I see.
Never mind. We're gonna say next one. We're gonna do next.
All right. Solve the equation. They say to graph the solution. We're not going to do the graph part. We did enough with the graphing yesterday, so we're just going to solve. So 10, the absolute value of y is equal to negative 5.
So.
Y equals -5.
Can an absolute value ever be equal to a negative number?
No.
No.
So
Why
it's
is
not
it-
a s-
No,
So there's no
No
solution.
Oh. What's your favorite type of math?
What do you mean? Like my
Like-
favorite class?
Yeah.
Uh-huh.
Either this or pre-cal.
This.
Is a lot of numbers, I think.
Pre-cal is just a slightly harder version of this.
So like. Wait, what do we take next year?
Pre-cal.
Oh,
so
yay.
Wait, who was in our class? Just the same class.
Probably the same people.
Yeah. 14. The absolute value of h minus 4 is equal to 4. So with absolute value,
H
N is either 8 or H. H.
Wait,
oh.
H
H
plus
is either
4.
8 or negative. I mean,
H.
okay, so it's two separate equations. So we have that h minus 4 is equal to 4. We copy it exactly. Or h minus 4 is equal to negative 4. So h is equal to 8 or h is equal to 0.
Wait, how did the I can't speak. How did that turn to -4?
Because we have absolute value. This is saying that whatever's inside of here can either equal positive 4 or it can equal negative 4. Because if it's negative 4, the absolute value of -4 is positive 4. So it's always two equations with
Alright.
absolute value.
Like,
22.
What's on my shit?
The absolute value of 3g plus 14 is equal to 7. So I'm going to split it. Or not split it, but like rewrite it. 3g plus 14 is equal to 7. Or 3g plus 14 is equal to -7. So, so g equals -7/3. Or over here, 3g equals -21. So then g equals -7. Yeah. Me too.
I don't even have a snack or money for a snack. I don't have to.
Do you think they would ever like allow us to go down at little kid lunchtime to get a snack? Or no? I don't know. What is little
Probably not.
11?
it's easier stuff.
But if you don't have money, like cash,
I feel like
You won't.
they should do the key card thing
Yeah,
or
but it's not
credit
cash.
cards. It'd be so much easier. Take notes. Coach Stacy, take notes.
That's okay.
Next year. We would make so much more money.
I say next year.
Next year
Like
we
if
just-
we did
Oh.
key card stuff too,
Darn it, you don't have a
so
fridge
much
in your
more
room, do
money.
you?
No, I don't.
I will buy a fridge
And we could like sell like drinks.
But you can't.
because Mr. Law says no.
But he won't be here.
We sell water.
Yeah, but the handbook's not going to change on having drinks or not having drinks.
We don't.
Because that's not an issue of the drink itself. It's an issue of it getting spilled.
But don't
It's
sell
like-
it to idiots.
We should allow like
I
Oh,
don't know.
clear drinks.
no idiots.
That's what I was gonna say.
Yeah,
It's
if
like
you-
a longer
But
part.
clear drinks can
Yeah,
still be
well, what'd
sticky
you
because Sprite's
say?
clear.
I don't.
Yeah.
Something that wasn't bad.
A longer version.
26.
Exactly.
34. Solve the equation, check for extraneous solutions. So if the equation is like an absolute value and it's equal to something that has a variable in it on the other side, we need to check for extraneous solutions because it's possible that in solving it, we may have something that gives us a true statement when solved, but when we plug it back in, does not work. Okay, so we need to check them. So 34 is the absolute value of 3x minus 4 is equal to x. So we're going to treat this like we did the previous ones. We're going to set them up and split, or I keep wanting to say split them. We're going to set it up twice. So it's 3x minus 4 equals x, or 3x minus 4 equals -x. And I'm going to solve. So I'm going to subtract this 3x, so -4 equals -2x, divide by -2, 2 equals x. Then over here, subtract the 3x, so -4 equals -4x, divide by -4, 1 equals x. Now, I'm not done yet. I need to see if these actually work. So I'm going to check them. And I'm checking into the original. Okay? So I'm going to see if the absolute value of 3 times 2 minus 4 is equal to 2. Now, typically, as long as the number is positive out here, it's going to be fine, but we still need to check it and make sure. So this is the absolute value of 6 minus 4 is the absolute value of 2, which is equal to 2, so that one's good. So this one does work. Check the other one. The absolute value of 3 times 1 minus 4 is equal to 1. So that's 3 minus 4. So that's the absolute value of -1, which is equal to 1. So that's good. Now, if you have, like, say, more of a problem on the right side, then you obviously need to work it down and show that the left is equal to the right. But in this one, we're
only
solving.
one is right.
Then we would say that the other one is extraneous. A lot of times only one will work.
Okay.
This one, they both happen to work because both of these were positive and it was just an X out here. So I pretty much could say right away that it was going to work because this was going to be a positive number. But like with 38, this one is the absolute value of 9 minus 2x is equal to 10 plus 3x. So since this is more of a problem out here, I'm going to need to check and make sure that it works. I mean, more so than the other ones. So, set it up. 9 minus 2x equals 10 plus 3x. When I set it up the other way, I've got to make sure that I put a negative on the whole thing. So I'm going to go ahead and just write both as negatives, but know that if, say, that 3x was already negative, I would need to just change the sign on it as if I'm distributing. So then 9 minus 2x is equal to negative 10 minus 3x for the second one. So just so it's not confusing, I'm going to work the left one all the way down and get an x equals, and then I'll do the right one. So I'm going to move my x to the left, numbers to the right. So subtract 3x, I get negative 5x is equal to, subtract 9, so that's 1. So then x is equal to negative 1/5. Then over here on the other one, I'm going to do the same thing. I'm going to add the 3x over, so that's equal to x. And then negative 19. So those are my two values. Okay, the one that, well, actually, they both could cause a problem because they're both negative numbers. Okay, basically when you see a negative, that's when you should be thinking this probably is going to be an issue or it could be an issue. Typically, if they're positive, you're not going to have to worry about it, but you still have to check them. So I'm going to plug these in and check them. So I have the absolute value of 9 minus 2 times negative 1/5 is equal to 10 plus 3 times negative 1/5. So I'm going to go ahead and get a common denominator here just to save a step. So I'm going to put this over 5. So that's going to be 45 over 5 plus, because I have negative times negative, 2 over 5 is equal to, I'm going to, again, go ahead and get a common denominator. So 50 over 5 minus 3 over 5. So inside here, this will be 47 over 5 equals, over here, subtracting, that gives me 47 over 5. These are the same, so this one is good. Huh?
You can already tell by looking at that one that's not gonna work.
Yeah, because 3 times negative 19 is certainly larger than 10, so you know it's going to end up being negative. But we do need to just show it just so that you can see it. But yes, this one will be extraneous for that reason. But the absolute value of 9 minus 2 times negative 19 equals 10 plus 3 times negative 19. So that's 38. 9 plus 38 is, am I struggling? 47 is equal to 10 minus 57. So negative 47 is equal to positive 47. That's obviously not true. And so this one is extraneous. So that's how you need to, O-U-S, yeah. So that's how you need to label this one, is that this other one is extraneous. So the only one that actually works is negative 1/5. I know it's annoying to have to check them, but I can pretty much guarantee on the quiz or the test, one of the solutions is going to be extraneous. So if you don't check it, I'm going to know, because you're going to end up putting both answers down. Because every year people don't check the ones to see if one's extraneous. So just ingrained now, I need to check these to make sure that they work. So those are all equalities. We also have absolute value inequalities. And so whenever we set up our two different inequalities for absolute value, remember that we have to change the number like we do with an equality to make the one on the right side, or whatever side doesn't have the absolute value, negative. But we also have to flip the inequality over as if we multiplied or divided by a negative. So one's copied exactly, the other one is a flip and a change of the sign. So 46, the absolute value of n minus 11 is greater than or equal to 1. So the first time is exactly copied down just without the absolute value bars. So n minus 11 is greater than or equal to 1. On the other one, I guess I shouldn't necessarily write or, but this is greater than, so it is going to be an or problem. But is n minus 11 is less than or equal to, so I flipped it and I'm going to make it negative 1. So I have then add the 11, n is greater than or equal to 12. Then over here, add that n is less than or equal to 10. So my final answer should be n is less than or equal to 10, or n is greater than or equal to 12. Because they need to be in numerical order. Because if I were to graph these, then now they're ready to go. I presume y'all remember land and gore, less than and greater than or. Algebra 1, maybe, sort of. All right, 48, the absolute value of f plus 6 is less than 2. So copy down exactly. F plus 6 is less than 2. And then f plus 6 is greater than negative 2. This is a less than, so it's going to end up being an and. So subtract the 6. F is less than negative 4. Over here, subtract the 6. F is greater than negative 8. So f is greater than negative 8 and less than negative 4. So I'm going to have negative 8 is less than f is less than negative 4. One thing, there's only like one problem in the whole section that is like this, but if you had, I'm just going to do a modified of this problem. If you had the absolute value of f plus 6 and then outside the absolute value like plus 10 is less than 2, before you split it, we've got to move the 10 over. So just remember to do that first. So f plus 6 in the absolute value is less than negative 8. And then you could do it where you do your two separate things. So, like I said, there's literally only two in the section that are like that, but just as a refresher. So, questions, comments, concerns? All right, problems 9, 17, 25, 35, 37, 45, and 55.